Here is a problem which has been seen in the test so many times. Linearly dependent or independent vectors. The question is, given the figure, and this figure I haven't drawn so well, but it is rectangular prism. Okay, so take this as a rectangular prism. Given the figure, classify the following sets of vectors as either linearly dependent or linearly independent. So first set of vectors here is AB and AE. So AB and AE, are they linearly dependent or linearly independent? That's what you have to write. The second one is EF and BC. So EF and BC. The third one is set of three vectors which are BC, DF and GB. So BC, DF and G to B. The fourth one is CG and EH. CG and EH. There it is. And the fifth one is AD, HC and GE. G to E, right? So you have to classify these vectors, these set of vectors, as dependent or independent, right? So first do it and then look into my suggestion. As I said, I've seen this problem so many times in test paper. It's very important to understand it, okay? And it actually gives you concept and makes you understand what is dependent and what is independent, linearly dependent and linearly independent vector. Okay, so let's start off with AB and AE. So when you see AB and AE, as you can see, they are not parallel. So whenever we are talking about a set of vectors with two vectors in it, so two vectors are linearly dependent only if they are parallel, right? Since these two are not parallel, this set is linearly independent. So I'll write I for it. So you can check your answers and also the reason. EF and BC. So EF is here and BC is here, right? So you can see EF is actually parallel to BC, right? So they are parallel vectors. So these two vectors are dependent. Since they are parallel, they must be dependent, right? You can write one in terms of another. Now we have BC, DF and GB. BC is this vector. D to F. D to F is this vector. Let me just color them, right? BC, D to F and GB. So G to B is this vector. Now these vectors, are they linearly dependent or independent? This is the decision you have to make. Now whenever there are three vectors, they will be dependent only if they are in the same plane, right? Now vectors can be translated. So we can translate DF from here to this place, correct? So this is same as DF. CG is equals to DF, right? Think like this. DF. DF is actually equals to CG, right? Now if you replace DF by CG, then you can see that they are in the same plane, right? We can have a linear combination where the combination of these three vectors can be equal to 0, right? So these are actually dependent vectors. Now the next one is CG and EH. So C to G is this vector which we're talking about. Let me change the ink now. CG is this vector, CG, and EH. So E to H is perpendicular. So they are in different directions, so they are not parallel, and therefore they are independent vectors. Now we have AD, HC, and GE. So let's look into this set of vectors. A to D, HC, so H to C is this diagonal, and then GE, G to E is this diagonal, right? Now these are all in different planes. They are not coplanar, and therefore they are independent vectors, correct? So that is how we have to answer this question, right? So why this is independent? Because they are not coplanar, they are in different planes. Why this is independent? Because they are not parallel, right? They're like that. You need to give reasons to your answer, and I hope with this you understand what is linearly dependent and what is linearly independent set of vectors, correct? So remember, two vectors are linearly dependent if they are parallel, very simple, and three vectors are linearly dependent if they are coplanar, very simple. So coplanar and parallel is the key word for you to decide whether the vectors are linearly dependent or not. And if a vector is not linearly dependent, then it is linearly independent vector, correct? So that is how it goes. I hope you understand. Thank you.